Hello class, today we're going to work on sectors of circles. And actually, we reviewed a little bit of sectors of circles already. So we're going to start off with the formulas that we went over in class. So to review, let's draw a circle and define what we're looking at. As a reminder, we have some origin, initial ray, moving toward some terminal ray, making this angle theta. And we have this arc measure here, and let me use a different color. This area here is going to be the area of the sector. So let's take a look at that, and actually I'll denote the arc measure in green so we can denote a different color. And we'll review the formulas we defined in class. So below I have this crudely drawn table that's going to help us remind us what we're working with when we're looking for arc length and area. And that's really dependent on what our angle is given in based on degrees here or in radians. So if it's given in degrees, we have a base formula that's going to be theta over 360 degrees. So this is the part of the whole multiplied by 2 pi r, which is the full revolution of the whole circle from basically 0 to 360 degrees. Now, if we're looking at it for radians, that's going to be simplified into a much easier formula of s equaling r, the radius, times theta. Now, as we look at area, again, it's going to be part over whole, where we have our given angle theta over 360 degrees. I'm denoting degrees for both theta and 360 here, just to remind us of their units, multiplied by the total area of the whole circle, or the whole revolution, pi r squared. Now, as a reminder, if we had a simplified version to say that 1/2 r squared times theta would give you the area if it was in radians. And as a reminder, r is your radius and theta is your given angle. So with these formulas and relationships, we're going to try and apply it to a given problem. So example 1 states a sector of a circle has arc length 6 centimeters and area 75 centimeters squared. Find its radius and the measure of its central angle. Now for this one I'm going to state let's do both in degrees and in radians. I urge you to take a moment and make an attempt at trying to solve this on your own. I'm going to walk through the process on how I do it myself. So at this point I love to start these types of problems with a drawing, because why not take a break from math and you get to draw a nice circle. Well, you try to draw a nice circle. And in this case, I want to only care about the sector which I'm drawing here with my angle theta. And it has some arc length, 6 centimeters. So I can really care about this area here, well, the sector here I should say. And in this case, we also have a relationship for arc length, which was s equals theta times r. Notice I'm keeping this in radians because I like this formula and it's easier to work with. But I also can write it as the area, which area is equal to 1/2 theta r squared. With these relationships, it's going to actually be super beneficial when we're trying to solve for the radius and the measure of the central angle. Now you could end up doing double equations, since you have two different equations here, 1 and 2, and end up substituting in formulas. You could do that, or you can actually combine them in a way. In this case, let's look at our area one and suggest, well, if we have 1/2 theta, well, r squared, we can say 1/2 theta times r multiplied by another r. Well, what's important here is to note we've seen this part before right here. So we can just simply substitute this in for this. And we end up getting 1/2 s, let me put that in green, s and then multiplied by r. And that is now our new formula for finding the relationships between SR and the area that we're going for, which is A. So this is really helpful for us, especially if we're trying to find, again, the radius when given arc length and area. So we can just straight plug these in and end up getting a nice workaround method to solving this question. So 75 centimeters squared equals 1/2 multiplied by the 6 centimeters, and we're looking for R. And I'll actually do R in another color so we can show what we're looking for. I typically like to write the units, but you don't always have to. At this point I'm going to drop them now that I've already included them and know what I'm working with. Divided by 6 equals R. There we go. In the end, you get a radius that is equal to 25, and the units are centimeters. And that is your radius. Now, that doesn't give you your central angle yet. You can actually just bring this back, and I would typically use the simpler formula, at least simpler to me, and use that to find our angle theta. So in this case, we have 6 centimeters divided by 25 centimeters. I move the area divided by the radius is equal to your angle theta, remember, and that's in radians. So 6 divided by 25 using my calculator, and you get 0.24. Notice there's no units here because these cancel out. All right, this is in radians, and this is your angle theta, 0.24. That's in radians. Now let's just, why not do it in degrees? So in degrees, if we're converting that, remember, 0.24, I'm going to use a different color for this. You want radians in the denominator. That is pi, to get rid of the radians units, multiplied by 180 degrees. And you get an answer of 13.75 degrees. And that is your other angle theta. So that was our review on area of a sector and arc measure of a sector.